Hey guys, so disclaimer before this video gets started, we are all student athletes and we were not able to meet up to form the video and the podcast together, so there are separate clips put together.
Hey guys, so I'm going to be talking about black holes and what they look like. Black holes themselves are invisible since they swallow up all the light. The stuff around them looks like a whirlpool of gas and dust, but that's named the acceleration disk. As for the layers, there's the event horizon, and it's like what some people would call the point of no return. Once something like that crosses the boundary, even if light, it can't come back, so that's why it got that name. There's the ergosphere, which is a region around the black hole where the space itself gets dragged along into the black hole's spin. There's the photon sphere, which is close to the horizon. Light can get trapped into it in a circular path. And then there's also the acceleration disk, and it's like a swirling storm of gas and dust spinning around the black hole. There's the singularity. It's the very center of the black hole. There's a super tiny point. It has a lot of stuff squeezed into it. There's not really like a scientific term for how much it is, but it's a large amount. And then lastly, there's the relativistic jets. I'm sorry, I hope I'm saying that right. Sometimes black holes shoot the powerful jets of particles into space, and that's why it's called a jet. I guess that's where I get that name from as well. So that's all the looks and layers of the black holes, and yeah.
Okay, so a black hole is a region of space-time where the gravitational pull is so strong that nothing, not even light, can escape from it. This phenomenon occurs due to the extreme curvature of space-time caused by a concentration of mass within a relatively small region. At the center of a black hole lies a point known as a singularity, where the mass of a black hole is thought to be concentrated to an infinitely small, dense point. Surrounding the singularity is the event horizon, which we also call in class the point of no return. This is the boundary beyond which no information or light can escape due to the intense gravitational field. Black holes come in various sizes depending on their mass and or depending on the mass of the collapsed object that formed them, and they have several key properties such as like mass, the event horizon, the singularity. Black holes form through a process known as gravitational collapse, typically following the evolution of massive stars or as a result of the gravitational interactions within dense regions of space. So overall, black holes form as a consequence of gravitational collapse, where the overwhelming gravitational force overcomes all other forces, leading to the formation of a singularity surrounded by an event horizon, which is the point of no return.
Okay, I'm going to be talking about the different types of black holes and how they're unique in our universe and how they differentiate from one another. So starting off, black holes are based off their mass, formation mechanisms, and other characteristics that make them unique. So starting off with stellar black holes, these form from like massive stars that collapse under their own gravity after exhausting their nuclear fuel. So they have masses ranging from like a few times of the sun to 100 times the sun's mass. Moving on to intermediate mass black holes. So these are more massive than stellar black holes, but smaller than supermassive black holes, which we'll touch on more later. Their existence is still somewhat speculative, but their evidence suggests that their presence in some dense star clusters and galactic nuclei. So getting on to supermassive black holes. So these are found at like the center of most galaxies, including our own Milky Way. So these are monster billions times of what like the sun is. So they likely form through like the accumulation of mass over time, possibly through like the merging of smaller black holes and the matter of like the surrounding environment. And then we get into primordial black holes. So these are a more hypothetical black hole. They are thought to have formed in like the early universe, so there's still a lot of unanswered questions about these, but they have extremely density fluctuations during like the Big Bang theory. So they could have had a wide range of masses from like tiny micro black holes to like comparative to stellar black holes. Then we touch on micro black holes. So these are speculated to exist by some theories of particle physics. They would have masses much smaller than stellar black holes, possibly even smaller than an atom, so very small. They could have formed in the high energy conditions or the early universe and through like exotic processes. And we get to rotating black holes. So this is a part of the Kerr black hole. So according to Einstein's general theory of relativity, their black holes can rotate. So a rotating black hole, also known as the Kerr rotation black hole, has like fascinating processes, including like a region called the ergosphere, and where objects can be like dragged along with the rotation of a black hole. And then we finally touch on charged black holes. So in theoretical like physics, black holes could have an electric charge. These charges in black holes described by Reissner-Nordstrom metric have properties different from uncharged black holes, including the possibility of naked singularity. So, which is a singularity not hidden behind an event horizon. So these are many different types of black holes envisioned by like theoretical physics. So not through all like direct observation or confirmation, but like ongoing research that, especially through like astronomical and observations and experience, continues to deepen our like understanding of all these inanimate objects. So yeah.